Legacy software represents historically developed valuable logic, tied to languages and frameworks that have become difficult to maintain. A defensive strategy is a reactive approach, focusing on preservation and life extension rather than evolution. A defensive strategy relies on minimal patches and manual workarounds to manage risk. Teams are forced to train junior developers in antique programming environments just to maintain the status quo. Or they retain retired experts as consultants to keep the lights on. All of these actions buy time, but none of them create new value. Unlike a defensive strategy, a Python conquest unlocks the value and goodies of the Python ecosystem. This approach provides modularity, modern IDEs, and versioning tools like Git. It turns code into auditable documentation. The actuarial ecosystem provides NumPy, SciPy, and specialized libraries for pure vector speed. Visual diagnostics with Plotly and Seaborn reveal insights that legacy environments never showed. Automated rigor via PyTest and statistical tests ensures certainty before it hits production. But how do we bridge the gap from legacy to this new standard? We'll now show how an AI-based strategy can unlock this value at scale. Attempting a direct, one-shot translation of legacy monoliths into Python may not work smoothly. Using a generic LLM with a simple prompt to translate code may miss the architectural intent. In practice, this results in a fragmented mess of legacy logic in a new syntax. It creates bugs and AI hallucinations, and it fails to unlock the modern Python ecosystem. This approach is risky. It may translate the complexity into a new, unmanageable language. Enabling the conquest of Python value requires a detailed prompt to map the landing zone. A scan that analyzes the legacy code decomposes the legacy code into specific modules with strict interfaces. This topography allows other, deeper prompts to create the value. The output follows a fixed template. First, the LLM establishes documentation and justification for the architectural choices. The legacy code is preserved as documentation of the original intent. A report by the LLM justifies the selection of modern Python libraries and visualization techniques. The translated code arrives in a clean, professional structure. Test procedures using Python test libraries will be proposed by the LLM, and the user may provide test data that will be integrated in the test and validation process. Finally, the LLM will propose a robust Python test harness using Python libraries that ensures the logic remains solid over time. To conclude, let us look at some practical advice for your Python journey. Make your prompts detailed and watertight. Leave little to no room for freedom of interpretation or hallucinations. Provide halting points. Human supervision and guidance remain essential to the process. Maintain rigorous versioning. Apply date and timestamps to all prompts and artifacts. Prioritize logic transparency. Ask the model to justify its mathematical choices before generating code. And finally, untangle complexity. Small, decoupled modules are the key to a verifiable and robust system. Thank you for watching. You can find me on LinkedIn,